Good morning, children. We move on to the next concept, differentiability at a point. Differentiability, something that relates to change. Every point, every position in nature changes. So learning this concept is an ideal one. We need to learn how does it change. Let us define the differentiability at a point. Let f of x be a real valued function defined on an open interval a, b. See a point inside the interval. We say f of x is differentiable at x is equal to c if and only if limit x tends to c. F of x minus f of c by x minus c exists finitely. We have learnt limit in the earlier exercises. F of c is function value at c. So f of x minus f of c. Denominator without f you must write. That is x change. This is change in f. This is change in x. So change in f with respect to change in x we call derivative or differential coefficient. We denote it f dash, that is derivative of f of x at x is equal to c. In short, f dash of c or derivative of f at x is equal to c. Derivative d, capital D of the function f of x at x is equal to c. So d f of c. Another way, capital D can also be denoted as d by dx. Why I put dx? Change in x only comes in the denominator. So derivative of f of x with respect to x tells me x in the denominator. Derivative also we have from left or from right. So left hand derivative and right hand derivative. In this formula, wherever x is coming, I put c minus h, it is left derivative, and I put c plus h, it is right derivative. The same formula, wherever x is coming, we have put c minus h for left derivative and c plus h for right derivative. If left and right derivatives are equal, we declare derivative exists or f of x is differentiable at x is equal to c. Let us do one example to check the left and right derivative. Example 5.29 show that the function f of x equals mod x is not differentiable at x is equal to 0. We know mod x is always positive. If x is positive, take it as it is. If x is negative, change the symbol. So in both the cases, my answer is positive. What is left derivative and right derivative formula? Let us remember. Now I want to check at x is equal to 0. So left derivative f dash of 0. Limit h tends to 0, f of. Instead of c, I am checking at 0. So 0 minus h minus f of 0 by minus h. Or limit h tends to 0. F of 0 minus h is minus h. What is f of x? Mod x. So put modulus of minus h minus f of 0. Modulus of 0 divided by minus h. Modulus gives always positive answer. 0 modulus is 0, ignore. So I get limit h tends to 0, h by minus h My answer is -1. The same idea I proceed. Write derivative at 0. Limit h tends to 0, f of 0 plus h minus f of 0 by h. Limit h tends to 0, f of 0 plus h. 0 plus h is h. My question is mod x. So modulus of h minus modulus of 0 by h. I get modulus of h is h only. So limit h tends to 0, h by h. H by h is +1. Here I got -1, here I get +1. So I will say left derivative at 0 is not equal to right derivative at 0. Therefore, f of x equal to mod x is not differentiable at x is equal to 0. So in this problem, we remember the left and right derivative. L of f dash of c is f of c minus h minus f of c by minus h. In right derivative, f of c plus h minus f of c by plus h. As we substitute, modulus is always giving us positive quantity. Denominator minus h cancels and gives -1. Denominator plus h cancels and give +1. -1 and +1 are not equal. So left and right derivatives are not equal tells us the given function is not differentiable at x is equal to 0.